And we're back now on Thursday talking about some of the same concepts. So on Tuesday we looked at how do we write to a file, what kind of things we can do. We can append, we can write over the top of. Well, today we want to look at a couple of other things. So we learned about the pickle, and I want to go over the pickle real quick again. So a pickle is just a way to preserve data, put it into a chunk where we can utilize it over and over again. Pickling, though, requires us to take that entire data back out, use it, and then we can put it back. The shelving option takes a little more resources, and in fact, when we did the demonstration in class, you can see that it constructs not only that DAT file that a pickle does, but it also creates an index file that we showed you, and a backup to the index, because that's very important, so we can access that file randomly. So in other words, we can get to it, and we don't have to grab the entire piece of data. And that gets important as we get bigger and bigger files. So we can utilize that to grab data as we look at it. So make sure you've went along, you've looked at those examples. One of the odd things I noticed as I'm going through trying to grade all the assignments for last week, a lot of people didn't read the instructions. They didn't construct the program into a set of functions, and that was the intent, was to break it into functions so that you could then learn how those worked and how to pass variables. Well, not only can we pickle data and we can do the shelving, the reality is Python often interacts with data, and one of the powers that Python has is we can interact with data in other ways also. So one of the things you may have heard is something called XML. And XML is simply a containerized system that we can put data into. Another thing that we can certainly do with Python is access databases. So if you're taking a database class, those database files, we can actually embed SQL commands in Python and access databases. So it's very, very handy for that. Well, on page 205, kind of where we stopped and started, we want to look at something about an exception. So what is an exception? So an exception means an error. So in Python speak, an error happens and we do something to try to fix it. So if you've had errors, and if you haven't had any errors by now, you're one of the few students in class, it stops your program, and if I'm ready to the idle environment, it gives you a big red set of letters and does some things there. Well, that's handy, but it doesn't allow our program to continue running. And so what we're going to look at is how do we handle errors, because they are going to happen. How do we manage to trap those errors? And so sometimes in our code, we can do very, very good jobs of handling data and input. So if we inputted in a text string and try to convert that to a number or a float or something else. So in the example on page 205, you're going to find an error that says, hey, we couldn't convert a string to a float. And it's going to give you an error. Well, there's some programmatic ways. There's also some interesting ways then that Python itself can handle errors. So let me open up my Python editor again. And so we get a function called try. So the try statement or function, however you want to look at it, gives us the ability to put data in, try it, and we get a accept back. So in this particular case, and I'm going to scroll down so you can see just the very top. So we're going to try, and we have this idea of we're going to take a number and we're going to assign it the value of float input a number. And if somebody puts in the wrong value, we're going to see what happens. So let's run. Alright, so we're going to enter a number, and we're going to be good students this time. So that works. Alright, so in that case it didn't raise an exception. But now when we run it, we're going to be bad. Because I didn't, and my name is Harvey. Something went wrong. Well, normally what would have happened is that program would have crashed. And in fact, we can try that. So we could write a very quick program. So file new. We could run this and see what happens. So we run this module, yes, we're going to call it sample3. No, back up. Now we'll run it again. Enter a number. And notice that's what we normally get, because it says we couldn't convert that to a float. Well, what we'd like to do is somehow create a method that we can trap that error, so we can find that error, deal with it then programmatically. So in this particular case, that except clause, so let me go back to that really quickly. So that except clause, if this fails, so that try statement gives us kind of an if then else type of structure, so we can accept. We can say, oh, well, something else went wrong. Very, very handy. Well, on page 207, there's a table 7.6, which gives us a list of selected exception types. Now, these are the most common. There are more, but the except clause then lets us specify not only that there's an error, but we can actually specify what type of error. Oh. So our second piece, so let's get rid of this. We know now when we're going to run this program, we're going to run a second piece here. So we're going to do something very similar. It's going to input a number, copy, and I'm just going to put it again back into that a new file just to make life easy for us. New file. So we don't have to run all the other things, and there's no commenting, no coding, or anything else. Well, I'm going to run this, and of course it's going to say, yes, I have to save it. We're going to call it our sample3 again, yes. So enter a number, and if I enter a 10, it works fine. If I try to then run it, and I put in Harvey, it's going to say, hey, that wasn't a number. If we have any other kind of an issue, so in other words, it searched only for those where it's a value error. So it doesn't worry about if it's a name error or if it's a 0 by division error. It only worries about if it's a value error. And so that gives us some more control and more ability then so we can modify these then with those specific types. So we could say only in the case of a value error are we going to do something else. Well, what then if we have multiple types of errors? So here, so this particular code here, we can look at multiple exception types. So here we have a couple of values, and we're going to try to convert a value into something else. And we're going to print the float of that value. Now you're going to see if that's going to work or not. So here now, notice this on this except statement here, we list two different types. So we list a type error, and so if I look back up on my chart, a type error says when an inappropriate or raised when a built-in function or function is applied to an object of an inappropriate type. And then a value error says is raised when a built-in function receives an argument that has the right type but an inappropriate value. So that gives us the ability then to do multiple types of things. So I can put them in together like this. That's pretty common if I know that I'm going to have two of very similar types of errors. So a lot of times we know that a type error and a value error could be very closely related. I can also make multiple except, and so this gives you a power. So this has one error trapping routine. All it's going to do is say print. What it might do is loop back up and say that there's an issue. This particular module, so now if I have multiple excepts, notice what happens. So now I have an except for type error, and it says I can only convert a string or a number. A value error gives us a different error. I can only create a string of digits. So this gives us the power then to start looking at how can we trap those errors. So I'm going to run this entire program. So the first one, something went wrong, as expected. So that was not a number. So it tells us that. So this third version then, attempting to convert none, something went wrong, something went wrong. So in this next example then, remember we had a single, so let me move it over side by side. So this line corresponds to something went wrong here. In this particular statement then, it actually tripped one and then the other as it tried to convert those two values. Well, it might be handy to not only be able to trap certain errors, but it might be interesting to say, you know, wonder what Python is actually saying about that. And so we can actually get return values back of what Python is saying. So I'm going to type in, because I'm kind of an idiot, I just keep typing hap. That was not a number. Or as Python would say, could not convert string to float hap. So in other words, it's telling us that this is the error that's being returned, and we're able to output it programmatically and still run our program. So there's times when that might be a very handy thing. So if I look on the bottom of page 209, we call it the argument. So the exceptions argument. So we can also then, on page 210, we can add an else clause. So there's the ability here. So I'm going to try it again. Hap. That was not a number. Press the enter key to exit. So else, then, so if we get an exception, we can do one action. Else, in other words, if there's no exceptions raised, we can run our program. Okay. So in other words, we can use it as a fail-safe. And so if I look at that code, that else just says then, you entered the number. So if I try this last piece, and let me cut and paste it into a new document just to make life easy for all of us. So file new, cut and paste, then I'm going to run it. It's going to want me to save it. Yes. Sample 4. Okay, so we're in our window that we're running. Enter a number. I'm going to enter 10. And it says you entered the number 10. So it converted it into the number that we thought it was going to. It converted it into a float. In other words, it's got a decimal. So we put in 10. It converted it to 10.0. And it says you entered the number 10.0. So it gives us that value back. So that else statement ran. If I ran this again, and I put in hap, that was not a number. In other words, it ran the exception clause. So really this looks a lot like our if, then, else statements, except now we're able to take those inputs and we're able to, and still programmatically we can verify, and we can actually put in then an error trapping routine, and we can see what they've done, what's going on, and we can keep our program running using those also. So usually we would then loop back up and we would say, hey, please enter a number, you didn't enter it correctly. And so we can create those using using this try statement. So the game we're going to look at, and this is very important that you work along with the game, because the assignment for this week also, you're going to modify this very game. So the first thing we want to look at is how are we going to lay out things we're going to store in a file. And so on the bottom of page 210, we're going to call it a block, because that data is just stored continuously. So we'll look at it for an example here in just real quick in our folder. But right now, I want to look down at the bottom of page 210. And so they list in this block, there's a category, a question, answer 1, 2, 3, and 4, correct answer, and then an explanation. And in fact, that's a lot of very similar to how Blackboard internally stores data for quizzes. So we're going to look at the trivia, and we're going to open it up, and it's just a text file. And so if I look at this, so that first one is the category, second is the question, and then we have 1, so there's our question, and then we have answer 1, 2, 3, 4, and then we have which answer is correct, and then we have our explanation. So our explanation is a lamb is just a young sheep. Your question is, let's say you turn state's evidence and you need to get on the lamb. Well, what will happen? You'll end up on the, and then so it allows us to pick the correct solution. So we could create this and create a block of 100 different questions. We don't have to preload them all into the game to start with, or we don't have to put them inside our game content. We actually can write an input-output routine that will do that. So now I want you to notice also one thing up here. So right here, notice that little /. And so there's a couple of places you're going to see that. So you'll see it here, you'll see it here. Well, the reality is, of all the fun things that Python does really interesting, Python doesn't do a really good job of printing these out yet. It doesn't have a line return that'll default to the size of the window. And so you'll get things that'll run past the window. So make sure you look at that. And so that just breaks them up into about the size of a normal screen window. Now obviously on this computer I've got a very giant monitor and I'm looking at a lot of those, but what we're looking at then is our program. So this is going to work very similarly to what we think. So I'm going to open his program and we're going to look at it piece by piece really quickly. So I'm going to open that in idle and we're going to take a look at it in sample pieces. Now you really, and I don't know how to encourage you any more than that, need to work along with this book. I would even try typing it all in as you go, and that reinforces these skills, and you can look at these in pieces. So the very first thing we're going to do is notice that this is all defined in functions again. So if you're one of them that didn't do the functions last week, you really need to go back and look at how functions work, because we have to be able to pass these values back and forth from one function to the other. So if I scrolled all the way down to the bottom of the code, you'll notice my main program is only one line. It says main. And then we have a main function. So the first thing though we're going to look at, so if I looked at our main function, is it's going to open a file. So it opens that file, trivia.txt, and it begins and it grabs that title line. So if I remember from my file, which is here, if I have it right, so it gives a title, and that's the first thing it grabs out of there. So what we also are going to do here is notice that we are calling a function called openFile. So that openFile function, we have to pass in two pieces of data, the file name and the mode. Well, when I come down here, we're opening that function called openFile, and we're passing in the name of the file and the method. So in other words, just a read method for R. So it passes in those two values from our main function into this open file function. We use the try command here, so we're going to do trial or try, and that way if we get an error, then we know what's going to happen. So what if our name is spelled wrong? You didn't turn in the password file or the text file. So we're going to ask it first. So we're going to create a variable called the file, and it's equal to, and then we open file name in mode. So in other words, trivia.txt and in R mode. Except if we have an error. Okay. So the error then we're looking at as an IO error. And we're going to print unable to open the file blank ending program, and it's going to tell us why, and we're going to then get the ability to exit the program. And so you've got something new called system exit, and that just kicks us out of that program. So let's try something here. Let me close this one, and I'm going to go back into my file manager here, and I'm going to change that name just a little bit. So I'm going to add an extra A, because I had a little bit of misspelling. And so I'm going to run this program and see what happens. So the first thing it's going to do is says, hey, unable to open the file trivia.txt ending program. And then it lists, because we set that E value, error number 2, no such file or directory. And so that'll give us a clue then about what happened. Oh, I probably forgot to turn that in. I probably did something else. So I'm going to go back into my file folder, and I'm going to look at it and say, oh yeah, I did something silly. I changed that. And I put an extra A on there because I was a typo. Now I'm going to run it and see what happens. So now if I run it, now notice it runs through there. Because we trapped that error the first time, we had an option to escape the program. So that's one thing we can do. And so notice that gives us that most common thing, that IO error, and traps it and gives us away and lets us gracefully exit the program and tell us what happened and why it happened. So we have another function called next line. So as you notice, that file had a lot of lines in it. What we're doing here is we're creating a file called next line, and so this reads that one line at a time and returns it back. So next block, the same type of thing. We grab a block at a time and we define that block 1 through 4, and we'll show you what that looks like here in just a second. So I'm going to go back up to this main, and I'm going to look at what it does. So the first thing it does is it tries to open that file, and we looked at that function. Well, the next thing it's going to do is it's going to run that one called next line. So if I go back up to next line returns that first line of the code. So, and it does a little formatting, and you can look and see what it does. And then we print welcome. So we run the file called welcome, or the function called welcome. So here's welcome, and welcome then, notice we pass in that trivial file, that first line. So here it says welcome to trivia challenge blank, and so that title is passed from this function. We go retrieve it, and then it's passed into this welcome function. So we run the welcome function, and we set the score equal to 0. Now watch that score, because that's one of the things that your assignment is going to deal with, is that score. So next we get a block. So in other words, if I look at my text again, So I want to look at that trivia text. So it's retrieved this one, an episode you can't refuse. And now we're going to look at something else. So close that out. We don't need that. So it's going to return this into the welcome statement. And in fact, when I ran that, you'll see that's what it did. I've got a lot of windows open here. So chunk. We'll go back up and we'll open that up and we'll take a look at it. So let's run it one more time. So trivia challenge, we're going to run. And notice it says on the run with an mammal is the question, but welcome to the trivia challenge, an episode you can't refuse. Well, that episode you can't refuse is this line up here. Ah, okay. Interesting. So an episode you can't refuse. And so let's run the first question. You'll end up on the cow. So 2. Oh, wrong. And it says, yep, a lamb is just a young sheep, so it gives us our answer. And then it says, the Godfather will get down with you now. And so if I look at my text, it says, oh, a lamb is the wrong. And then it gives me the title for this next one. The Godfather will get down with you now. So we're just reading these in blocks to get through our code. Okay, so let's edit it. So we can get it back into Python and we can look at it. So the next block routine gets a block at a time, prints that block, and it actually calls the function next line, and then it calls question next line. So in other words, it advances down through that file. And then we get answers. And so it's going to go through 4 answers. And then we pull the explanation. Again, we use that next line function. So we're pulling one more line down. And then this function returns a whole lot of things back. So it returns category, it returns question, it returns answers, it returns correct, and it returns an explanation. So 1, 2, 3, 4, 5 different things. And notice this one's actually a list of items. So let's see where that's called at. So notice here, category, question, answers, correct, explanation equals next block. So that's where it pulls all that information out in that entire block. So it then asks the question, so it prints category, prints the question, prints the answers for as many of them as there are. It gets the answer, so what's your answer, and it checks it. If your answer is equal to correct, it says right, and it adds 1 to the score. Else it prints, hey, you're wrong. In either case, it prints the explanation, and it prints the score. It then says, oh, okay. So remember up here, this is that priming the pump. So we got our first set of values. Now we have to get our next set of values out of this category. And as long as those categories exist, it can run. And when it ends, then it nicely closes that file for us and says that was the last function. Your final score is blank. So your challenge with this week, so make sure you work your way through there and see how all this works. So your challenge this week is you're going to modify this program again. And that's one of the really handy things about Python is we can go in and modify programs very, very easily. So you're going to go modify this program. And so you're going to modify it in a couple of different ways. You're going to add different values to each question. And so it'd be handy if you even maybe made up some additional questions. And you're going to add values to each one. So different questions can be worth different points. You're also then going to have to keep track of your high scores. And so you can run it at the beginning of the program, you can run it at the end, you can run it 12 times in the middle. You're going to have to pull out from a high score list previous high scores. So that'll take some thinking. It'll take some editing of your text file. In other words, you're going to have to change what's scored in there, because right now there's no scoring associated with that stored in there. And so how am I going to score another line that's got a point value for each question? How do I do that? You'll have to figure out a way to score and where you're going to put that score, a high score value, and how you're going to deal with that. So it sounds pretty easy, but again, this is a pretty challenging change, and so you need to make sure you understand how this program works. So work your way through it. Try these pieces individually. Try adding content into the text file and see what happens. Can I make it function? Can I intercept? Can I add another line? What can I do to do this? So there will literally be 330,000 different possible methods. How are you going to do it and make sense?